Okay, I'm going to just do a few practice problems from section 4.4. 1 and 2 just ask you to write the equivalence in converting from a logarithm to an exponential and vice versa. So the first one, the natural log of 2 is 0.69381. If you exponentiate both sides, e to the natural log of 2 equals e to the 0.6931. On the left-hand side, e to the natural log of 2 is just 2. So that's like saying 2 is equal to e to the 0.6931. And on the second one, if you take the natural log of both sides, the natural log of e squared is just 2. And the natural log of the right-hand side then would be natural log of 7.3891. And you should check that with your calculator. Take the punch in natural ln, should be a button on your calculator, of 7.3891, and you should get 2. Okay, number 39, we're supposed to use these two facts. The natural log of 2 is about 0.693, and the natural log of 3 is about 1.0986, and you're supposed to approximate these values. So the natural log of 6 is natural log of 2 times 3. Think what properties you would use for that. I'll go down to C. Natural log of 81 is the natural log of 81 is 3 raised to the 4th power. And the last one, that's natural log of 3 raised to the 1/2. Okay, so in our properties, the log of a product is natural 2 plus natural log of 3. This one would be natural log of 3 minus the natural log of 2. With the exponent rule here, this would be 4 times the natural log of 3. And the last one, the exponent comes down front, 1/2 times the natural log of 3. So in each of these problems, then, you're just supposed to plug in what those equal. This would be 0.6931 plus 1.0986. I'll let you figure out what that is. Here, you subtract those two values. Here you would multiply 4 times 1.0986, whatever that is. And this last one would be 1/2 of that, whatever that is. Okay, so with calculators anymore, we don't use these properties so much with numbers. It's nice to use for simplifying expressions. When you have a calculator, you can just double check that those work, but that's all you do on those problems. Okay, let's jump up to number 77 now. The population is given as p equals 130 e to the 0.0205t. Hopefully you recognize that as exponential growth, and this is a function of t, so we could write p of t equals, but there's the function. And t equals 0 will correspond to the year 1980. So we have the two questions. What was the population? Oh, sorry. This is not 1980. The question says, what was the population in 2009? In 1980, when t is 0, you plug 0 in and you would have just gotten 130. And this says it's given in thousands. I should have written that here. Okay, so part A, in 2009, that is 29 years past 1980, so t would be 29. So p of the population in year 29, we would just plug 29 into that formula. 130 e raised to the 0.0205 times 29. I will come back later and plug in what those values are equal to on our calculator. Part B. When is the population equal to 300,000? In other words, we take our population at a general time t, and we set that equal to 300, because remember, the population is given in thousands, so 300,000, we would plug 300 into the formula. We have to now solve that for t. So we need to get all the variables on one side of the equation. I guess what we could do is we could divide by 130 on both sides, and we would get e to the 0.0205t equals 300 over 130, which would be 30 over 13. And then to solve for t, we could take the natural log of both sides, because we've seen in our properties that the logarithm undoes the exponent. So the natural log of e to a power, that just leaves us with 0.0205t. And on the other side, we get the natural log of 30 over 13. And then we just have to divide both sides by 0.025. So t, cancel that out, is the natural log of 30 divided by 13 all over 0.0205. Of course, that has a decimal value, and that'll be in years. So let me go calculate these. Okay, I went back and filled in. For part A, we got 130 times 1.812 in thousands, which came out to a little more than 235,000. And in part B, when I plug that in, I got t equals 21, which is 21 years past 1980. You get 2001, so the year is 2001. Okay, the last problem we'll do is we had this problem in class where the typing speed was given by this function 95 over 1 plus 8.5 times e to the negative 0.12t, and the question was, when is the typing speed equal to 90 words per minute? And we said we would set that equal to 90 and we must solve. So let's try to solve that for t. If we multiply both sides by the denominator here, we will get 95 equals 90 times 1 plus 8.5 e to the negative 0.12t. Okay, so we multiply this denominator, but the left-hand side right here, multiplied by the denominator, that cleared that out, and we're just left with 95, and on the right-hand side we have 90 times that former denominator. And let's see, we want to get that t by itself. I guess we could divide both sides by 90 now. And we have 95 over 90. And on the right-hand side, we just get 1 plus 8.5 e to the negative 0.12t. We could subtract both sides, 1 from both sides, and we would get 95 over 90 minus 1 is 8.5 e to the negative 0.12t. Notice I'm not using my calculator at all until the very end. Then I could divide both sides by 8.5. So I have 95 over 90 minus 1 is equal to this e to the negative 0.12t. Let's see, I guess to get rid of that, we will take the natural log of both sides. So I have the natural log of this 95 over 90 minus 1 all divided by 8.5. And the natural log of the right-hand side, natural log of e to a quantity is just that quantity. And now we just have to divide by negative 0.12. And on the right-hand side we get t. So that means that t is can pull out the negative, natural log of 95 over 90 minus 1, then you divide all that by 8.5. And the whole thing is divided by 0.12. I will let you figure that out on your own. Make sure you use parentheses appropriately. You might have to put parentheses around the numerator before you divide that by 85. And when you do it, you should get about 61.1. So 61 weeks. And your typing speed would be up to about 90 words per minute.